The next one we're going to do is number 8 on the trig identities review. We're asking you to find the exact value of cosine of 105 degrees. Now again, you have a couple of different options here. You could use half angle or you could use the sum and difference formula, but I'm going to choose to use a half angle because when I look at cosine of 105, I think to myself, well, 105 is exactly half of one of our known unit circle values, which is 210 degrees. So to me, using half angle seems like a good idea on this one. So the first thing you're going to do when you use the half angle formula is you're going to actually take and double 105, or you're going to double whatever degree measure you're given initially. So 2 times 105 is 210 degrees. So this, when we use the half angle formula, is what's going to take the place of alpha in that formula. So if you look at the formula sheet, cosine of alpha over 2, there we go, is equal to plus or minus the square root of 1 plus cosine alpha divided by 2. So again, what we're going to do, we're going to take 210, and 210 is what we're going to use to replace alpha. So it's going to look like this. Cosine of 210 divided by 2 is equal to plus or minus the square root of 1 plus cosine 210 over 2. Alright, so when you look at the left side of this, we're actually not going to do anything with this, but if you look, 210 divided by 2 is still equivalent to cosine of 105. So we're still finding cosine of 105, which is using the half angle formula to find it. So what we're going to do next, just like we do with the sum and difference formula, is any trig function that has an angle after it, we're going to replace it with its counterpart. So if you know the cosine of 210 off the top of your head, great. If not, if you use your calculator, since this one's in degrees, you want to make sure you switch your mode to degree mode before you type cosine of 210 into your calculator. When you do that, you should recognize it. I think when you type it in, it'll look like negative 0.866, which is the negative square root of 3 divided by 2, all divided by 2. Still underneath that giant radical with the plus or minus out front. We'll deal with the plus and minus at the end, but for now we'll just kind of leave it there. You can deal with the plus minus at the beginning or at the end, it really doesn't matter. I just choose to do it at the end. Okay, so when you look at this, you have a numerator, and within the numerator you have a 1 and plus this fraction. Now, just like with any fraction, if you want to combine them together, you have to get a common denominator. Easiest way to do that is to change this 1 into 2 divided by 2. So 2 over 2 is still equivalent to 1, which is why we're allowed to do that. So your next step should look like this. 2 plus negative square root of 3 all over 2 divided by 2. Still underneath that giant radical, plus minus out front. Now it's really not necessary to put the plus negative radical 3. I'll just switch it to a minus radical 3 in the next step, but for now we'll leave it like that. So what you see, you have a fraction in your numerator, and then you just have this lonesome 2 down in your denominator. So what I'm going to do is put that 2 in the denominator over 1, if this will let me. Okay, well, it's not really working, but imagine it's over 1. And then what we can do is the bracket trick where you take the outsides and multiply them together. Again, imagine there's a 1 down there. And you're going to take the insides and multiply them together. So what that would look like, you have that 2 plus negative radical 3 times 1. So it's really just 2 minus radical 3. And then the new denominator is going to be 4. Now we could draw in that giant radical now, but since we have a single fraction, it kind of makes sense just to give them each their own radical, which is great because in the denominator, square root of 4 is just 2. And then up top, we have 2 minus radical 3, still all underneath a radical, which looks kind of awkward, and it is, but it's the best we can do. But now we need to decide if we want to keep the positive or the negative, because you're not going to keep both. And it goes back to cosine of 105. 105 degrees is in the second quadrant. So somewhere, let's say up in here. And if you think back to when we talked about the unit circle, we have this nice little acronym. All students take calculus. What that means is in the first quadrant, all of your trig functions are positive. In the second quadrant, only sine and its reciprocal are positive. In the third quadrant, only tangent's positive. And in the fourth quadrant, only cosine is positive. So since 105 is going to fall into the second quadrant, what that means is in the second quadrant, only sine is positive, which means cosine of 105 degrees is going to be a negative value. So I'm just going to stick that negative out front, and that's my final answer. Just like you did with the sum and difference formulas, you can absolutely check this in your calculator, and I highly recommend that you do. You're going to type 100 cosine of 105 into your calculator. Make sure you're in degree mode, and then you're going to type the final answer. Be careful how you type it in. If you have that fancy fraction button, as I like to call it, I would highly recommend you use it for this. If you have a TI-83, you're just going to have to make sure that you use parentheses for your grouping symbols very wisely. But these two answers, these two values should match each other exactly.